Right, now that we've looked at how to describe whether a box plot is uniform, symmetric, or skewed, we're also going to look at how the mean and the median compare in those distributions, and then we're going to put this into practice. All right, so we're going to start by looking at a symmetric distribution, and we've talked about this a little bit earlier. In a symmetric distribution, the mean and the median are roughly equal. So if it happens to be a bell-shaped curve like this one is, it's in the picture, then that high point is going to be where both the mean and the median are located. And they should be pretty close in value to each other. If it's a skewed distribution, and a skewed distribution on one side, there's going to be a part where the distribution trails off, so it has a long tail. And when that happens, the mean is always further out in the tail. So in a left skewed distribution, the tail is on the left side, which means the mean is also to the left. Okay, and the median will be closer to the high point, so the median is going to have a bigger value than the mean. And then similarly, if it's right skewed, then the tail goes to the right side, which means the mean is to the right. Okay, and so that means the mean will be bigger than the median. All right, so we're going to go ahead and put this into practice. We're going to go back and look at both of the mid-cars and the travel time plots. And those are, I think, on pages 4 and 5. So go ahead and pause the video and see if you can determine whether these are uniform, symmetric, or skewed, and then whether the mean or the median is going to be bigger in value. All right, so hopefully you gave that a try. Let's start with this mid-sized one. So here we have this distribution, and the whiskers actually look about roughly the same size, but there's a whole stack of outliers here. So if you add those outliers to the whisker itself, it makes that top part of the box plot a whole lot longer. So that skew is on the top part, which means that this is going to be right skewed. So one way you can think about that is if you take the box plot as it is and you tilt it on its side, so the bigger numbers are on the right, smaller numbers are on the left, so standard number line, then that longer side is on the right. So this one is right skewed. When it's right skewed, that means the mean is to the right, so the mean will be bigger here as well. We can actually tell that because Excel puts the mean on the box plot. So the mean is the X and this line is the median. So that mean definitely is bigger than the median. Right, and then one more, the travel times. So I didn't have you do these separately because they're actually both skewed the same way. So again, both of these have the longer whisker coming out of the top of the box plot, which makes both of these right skewed. And then the mean that is also bigger than the median.